Now, an exponent rule that you learned in the past, when you divide exponentials with the same base, you probably remember that you subtract the exponents in the order of the numerator's exponent minus the denominator's exponent. Now, what operation is bonding the two separate exponentials to separate exponentials outside of the two of them? And tell me in chat, what operation is bonding the two separate exponentials outside of the two exponentials? What operation is that? Somebody type into chat or unmute and you can say it out loud, because I want to make sure that you're all following me. Thank you very much. Division. This division bar is bonding two separate exponentials, but not inside of them, just between the two separate exponentials. Now, this rule condenses the numerator, or not the numerator, sorry, condenses so that inside that exponential, inside one exponential, what is the bond? What is the operation bond between the exponents inside of the exponential? Good. Subtraction. And it is definitely worth repeating. Inverse functions swap x and y. That means that one functions, and let me go to that typed, that one function's input inside the function swaps with its inverse function's output outside the function. So we're looking at inside and outside. And when you bring that into a log rule, that creates a log rule very similar to what we learned yesterday. The exponent rule subtracts two separate exponents inside of its function. Outside two separate logarithms, where logarithms are themselves exponents, if you have two logarithms that are separated by subtraction, that can be condensed into one logarithm, where the operation inside that logarithm is division, where division was outside the two separate exponentials. And it helps if you read this as, when you see this subtraction of two logarithms, that is the same thing as this subtraction that you see inside of that exponential. The operation between the two exponentials is just subtraction to connect them. But this time, logarithms are the entire expression. And it's, again, kind of similar to if you were to take some kind of, like you could take a tennis ball and you could cut it and you could turn it inside out. There's an interesting relationship with the two of those. But I'm not going to get into the metaphor of all that, just, kind of understand the idea of what I'm trying to show you. Oh, what was my notation note? Oh, yes. Yesterday, I explained to you that you don't need the parentheses with multiplication. You also don't need it with division. If you see a logarithm written this way, know there is an understood parentheses around the x divided by y. So x divided by y happens first, then it's put inside the logarithm. Now, we are ready to do examples similar to yesterday, but now we have two logarithm rules. Like yesterday, we're going to expand and we're going to condense. Realize that when we are expanding, there are two log rules we are now using. Yesterday's log rule was if you are adding with the same base, that's multiplication inside. Today's log rule is if you are subtracting, you condense by dividing inside. If I'm expanding, I am starting with these, and I'm using the rule to go this direction to these. So here we go. We're starting with one that's just using the new rule. You see inside the logarithm division, so you can expand the logarithm where you separate the x from the 5 into separate logarithms, and you are subtracting those two logarithms, and that problem is done. That is expanded. If you see how to expand without showing steps, I'm okay with that. Some of you are going to see that. I'm going to do the problems in a step-by-step process so I don't lose anyone. So I'm going to start with this. We have a division between two things. That means I'm going to subtract log base 2 of the numerator and log base 2 of the denominator. And I'm overemphasizing with parentheses. The parentheses aren't needed. This is not fully expanded. You are done expanding when you no longer have multiplication inside a logarithm or division inside a logarithm, at least with the rules we have so far. We'll learn another rule later, but right now you only have two rules. So make sure that if you look in this logarithm, nothing is multiplying or dividing inside that one. But if you look inside the first one, 16 and a are multiplying. That can expand further. So the next step is to take that first logarithm and separate the multiplication of the 16 and the a. And the rule is that the two logarithms are adding if the insides were multiplying. And then I still have the other piece. I have expanded at this point, but the directions go on and say simplify wherever possible. So again, this is expanded, but now is there anything you can simplify? And where I want you to look is where you have a number in a logarithm. Log base 2 of 16 might simplify. Does it simplify? You got it, exactly. You're looking at the answer to the logarithm is an exponent on 2 to the power of, where you get out of 16. So 2 to the power of 4 is 16. So that's now a 4. And then write the rest of the expansion. And that is now expanded and simplified. Okay, and then a little bit harder. Again, I'm going to do this step by step. If you see a faster way than what I'm doing and you're getting the correct answers, that's fine. I'm going to erase to just get this out of the way. Okay. First thing I'm going to point out is you have a big division bar, and there's an understood parentheses for the numerator denominator. So I'm going to split that division into a subtraction of 2 logarithms. Yes. And no, it's actually, that's why I said if you can do this in fewer steps, feel free. I'm going to do this in a certain methodical way to make sure that I don't lose anyone, but it's not the only way to go through the problem, and you might see it faster than what I'm showing it as well, which is fine. You can go about it in whatever way that is a correct method. So what I did was I just chose to first separate that division bar, and then everything left is what we worked with yesterday, multiplication inside of logarithms. So we separate the multiplication into 2 logarithms by adding and putting each of the factors into separate logarithms. But I want to tell you to mind this subtraction sign. We are subtracting whatever comes after that subtraction sign. I'm going to put a big parentheses so that things don't get accidentally messed up. Now, while I'm looking at this piece, I see multiplication. That means that that logarithm can be split by addition, where each of the factors in the single logarithm become separate inputs of logarithms that are adding. Now I want you to look carefully. Do you see why I said parentheses here? I need to distribute that negative sign over my parentheses. And I want you to take a good look at that, because a very, very most common mistake here is to put a subtraction here and then just bring the subtraction down, but to accidentally not be thinking about it and use this plus here. So be careful with that. But I also want to point out to you that every factor in the denominator wound up being a logarithm that was subtracting. And if what I said makes sense to you, then you might be seeing a way to more quickly go through the process of expanding. Now, this is expanded because when I look inside, I don't see any multiplication or division. However, the next step is simplify. And the simplify is referring to when you have a number in a logarithm, you want to see if that can be simplified. So what number is log base 3 of 27? So just to point it out, the base 3 is this 3. The input is the answer to 3 to the power of something. And the power, what color should I use? The power that you need here is the actual number of the logarithm. Some people will bring the addition of the, or I should say the subtraction of the 3 in front of everything, but it doesn't matter what order you add or subtract in, provided it's representing the same thing. Now, really take the time to think about these two logarithm rules today. Really take the time to get these to making as much sense as possible, because these two rules are very similar. There's another rule coming, and before we get to that rule, you really want to have this sink in. And my question to you is, how much easier do you want your life to be in getting through this class? You will help yourself tremendously if you take extra time to study this pair of formulas. And with studying it, do your best to understand how I was explaining the relationship with the exponent rules, but also take time to just memorize them with flashcards. So flashcards where you write one side of the equal sign on one side of the flashcard, the other side of the equal sign on the opposite side, and just continue to look back and forth in a forward direction and a backward direction. If you do that a bit today, it will make a big difference for you. It'll make your life easier. Now, condensing. Condensing into a single logarithm uses the same two rules, but now we're going the other direction. And you can choose to go quickly or fast, however you see things. I'm going to do it one step at a time. You can do this faster if you see it. I'm going to emphasize in red that I'm looking at an addition between two logarithms. And so when I condense that, I do multiplication of each logarithm's insides inside the condensed logarithm. And I'm just going to emphasize with these red parentheses what was affected. And now I have one last thing to do. I have a subtraction of two logarithms. That means I can condense what leads the subtraction, the insides, is the numerator. What follows the subtraction, the inside of what follows the subtraction, becomes the denominator. You are condensed when everything is in the logarithm, and so that is condensed. With this next piece, you can see these two logarithms condensing. So you have -3 plus, and then when two logarithms are subtracting, they condense, provided they are the same base. They are both base 5, where it divides in the order of the inside of the logarithm that leads the subtraction divided by the inside of the logarithm that follows the subtraction. This is not considered condense because I am adding something to the logarithm. That means that I need to change this number into a logarithm that uses base 5. The inverse of log base 5 is 5 to the power of something. And whatever this number is, make it an exponent where the base is the same number as the logarithm. And then that exponent that goes inside of an exponential, which then goes inside a logarithm, and they share the same base, becomes just that exponent. Mm-hmm. Absolutely. Yeah, it is confusing. And it's raining. Okay, sorry, I got distracted by the rain. It's just so unusual here in Southern California. Okay, so I've got this -3. I'm just going to bring this over and write it to the side. I want to write it as a logarithm that is base 5 because that's the base that I'm trying to bring it together with. And I need to make an input in this logarithm so that I'll get out an answer of -3. And I know this is still very confusing and it's very, very fresh. If we go back over to day 1, let me emphasize something from day 1. Let me go to the classwork. Actually, no, I had it. Here we go. Wait, did I write that as a general rule? I thought I had written that as a general rule. Okay. What we're primarily working with right now is this particular rule about the inverses. And it's an understanding of how if the base of the logarithm matches the base of the exponential, they are operations that undo each other. Just like if you went +2 -2, if you have +2 -2, they just don't need to be there. If you have multiplying by 2 and then, multiplying by 2 and then dividing by 2, these really don't need to be here. They undo each other. And what you want to try to do is to see, the notation is unfortunately awkward, but you want to see that this is the same situation as these two, in that log base 2 undoes 2 to the power of, and you end up with that power. From the one we were working with? Okay, so what I have there, let me make it more generic, because these need to match. So more generically, I could say log with a base b of b to the power of something is that power. And then you can look at if these are side-by-side operations, they actually cancel each other out. And this is actually a log rule that you have to be familiar with. And there are a lot of different ways to look at it, different ways to memorize it. And the most valuable thing is to come to understand what I'm trying to tell you, with the fact that it's two operations that undo each other next to each other. But if you do have to just get through by flat out memorization, it works. It's just, you're going to forget the exactness of the rules. If you don't understand them over time, you'll forget the exactness of the rules. If you are planning on going further toward the calculus route, you're going to need to retain this. If you are not planning on going into an area of science, in fact, I should be careful here. If you're going into any business major, you may have to deal with this again. Any science major, you are definitely going to have to deal with this again. And I just want you to know that to help you in your future. So as I come back over here, if that's beginning to make sense, then if I want to write -3 as a logarithm, I need to know what base I'm using, and then write that same base to the power of the number that I want it to actually be. And so then as we look back over here, this becomes an exponent where you're using the base that you need it to match with for your logarithm and the exponential. Now, in order to bring this, before I bring this together with the addition, I want to look at what's in this logarithm first. I'm going to rewrite it. I have log base 5 of 5 to the -3 power. And what you need to do is take a good look at what's in here, because now that is your focus of what does that simplify to. The negative exponent means 1 divided by that number to the positive exponent. And then what is 5 to the third power? So somebody put in chat, what is 5 to the power of 3? You got it. And now I'm going to do the multiplication. Or sorry, I'm going to deal with the addition between the two logarithms by multiplying the insides. I have log base 5 of 1 over 125 multiplied by the fraction w over z. And so that really means that the fraction is, for the numerator, 1 times w, the denominator 125 times z. And now that is condensed and simplified. And I realize that that's a beast. And you can get better and better at these if you keep asking questions and asking for help. Or keep looking over the notes, the explanations, maybe rewatch the video and study these formulas. I'm going to move on now to number 6, unless you have a question. I'm going to erase some of this in order to make room for doing problem 6. There are different orders you can deal with. Perhaps you realize that you have a situation of a base 49, but you have this lone number along with the addition and subtraction of logarithms. In order to bring that number into the logarithms to condense, you're going to need to write it as a log base 49. And since we just looked at this would be a great time to start with that. So I need to write it as a log base 49. And if I want a logarithm that simplifies to 1/2, then I want to use that same base, which is 49, and put it to the power of the number that I have, 1/2. Now, after you do that, you want to look at, let me rewrite this now, log base 49 of, you want to simplify what is in that parentheses, the 49 to the 1/2 power. A 1/2 exponent means square root. And what is the square root of 49? You got it. So that 1/2, it took a while to play with it, but it is the same thing as log base 49 of 7. And now I'm going to write the rest of what's there, minus log base 49 of m plus log base 49 of n minus log base 49 of p. Would you like to see a quick way to use both of our new rules quickly? Would you like to see a nice, neat way to do that? I'm going to assume the answer is yes. So what I'm going to do is I'm going to highlight in blue every subtraction. I'm going to highlight in yellow every addition. I want you to notice that there are 4 logarithms in that string, and I have highlighted 3 signs in front of those logarithms. For the very first logarithm that leads this, if you don't see a minus sign in front of it, we know that that means positive. There's an understanding that that logarithm is adding with the other ones. So if you look at the logarithms who are being added, when you condense, they are creating the numerator. When you look at the logarithms that are subtracting, when they condense, they create the denominator. So a quick way to condense, if you see that, is we've got for the positives a 7 and an n, and they multiply to make the numerator of the condensed logarithm. And then for my subtraction, I have input m and p. Those are going to multiply to create the denominator. You are allowed to do it that quickly if you see that and it makes sense to you. Otherwise, this could become very, very time consuming to do this slowly, one addition subtraction at a time. And then that is condensed and simplified. Now, we are running low on time, unfortunately, and I need to make sure that I get your quiz started soon. So understand that the rest of the classwork is very, very, very similar to the classwork we did 2 days ago, where I was teaching you how to work with graphing logarithms with a base greater than 1. This time it's a log with a base that is between 0 and 1. And if I keep going right now, I'm not going to give you enough time for the quiz. So here's what you're going to do. I'm going to make a second video, and you're going to watch that video. Either that or you can use the answers to the classwork to help guide you. And if it makes complete sense, you don't necessarily have to watch the video, but I would still recommend that you at least make sure that you listen to see that you're looking at everything the way you should. I'm going to stop this recording.